So let's move on to our next topic. We're going to talk about scalable robotic automation for multi-scope construction tasks in an evolving labor market. So we've got Gary Chen and Conley Oster here to share their ideas with us. If you guys turn on your video, and whoever's going to share the presentation, share that. Let me introduce you. So Gary is the CEO and co-founder of Raise Robotics. He leads company strategy, product development, and investor relations. With a background in robotics engineering and taking research to market, Gary is driving the company's vision for scalable, autonomous systems that improve safety and efficiency across the construction industry. Before Raise, he worked on autonomous vehicles, focusing on problems and transferring models from simulation work to the real world. He graduated from UC Berkeley, where he contributed to research on self-driving cars. Conley is the COO and co-founder of Raise Robotics, where he leads field operations, sales, and business development. Drawing on his experience in the construction project management, crane, and rigging sales, he brings field needs with emerging robotic capabilities to deliver practical, job-ready automation. So with that, I think you're going to find this really interesting. I'll turn it over to you guys to take it away.
All right. Well, good afternoon, everyone. And thank you, Gary, for the introduction. Today, what we're hoping to do is share a little bit about our company and how our journey of how we got to where we are today. In particular, what we really want to highlight is how some of the partnerships we made with our customers in our industry have been really instrumental in helping develop our product and being able to actually use automation to now help save our customers time and money on sites today. So just to kick things off, I'll start with a quick video of our robot so that you guys know what we're working on. We built these mobile manipulators that can either have a single or two arms, and they can drive around site to do work. And they're equipped with a set of different types of end effectors, basically a robot toolbox for different applications. This first one that you saw there is layout, drawing lines on site. And the second one is more of a prototype application that we developed for our customers to actually install components, these brackets that are used to hold up exterior walls or building facades. And on our robots, we make use of a lot of vision and force feedback technologies so that they can understand the environment around them and respond to variable conditions. With all the robots, we also collect data during operation, so our customers can have an ongoing track ongoing progress and see any potential issues that arise. And this is a new application that we've started running this year, drilling holes into concrete, where we're actually mostly doing this for retrofitting old buildings. All right. And moving on to the next slide. Sorry. Let me refresh the page. All right. And our vision for the company is to develop a modular robotic platform that we can apply to various repetitive applications on construction sites and also perhaps in other industries. Our vision here is to develop a set of different mobile manipulator platforms. Today, we have one that's really good at work on the ground and beneath the ground. And we're currently working on another version where we're going to be placing our arms actually on work platforms like scissor lifts and boom lifts and being able to do work overhead above the ground. And alongside our platform, we aim to develop a set of end effectors, basically a robot toolbox that will allow our machines to automate different applications on construction sites. And while this is the vision, today we're starting in a very specific spot. And just to walk things back a bit, when we first started a company, we actually spent a lot of time exploring different potential use cases in construction and trying to find an area where we could see automation really deliver value, both in terms of saving our customers time and also actually helping improve worker safety and productivity on site. And one of the biggest challenges we ran into is that construction work, even if we focused on just commercial buildings, it's very complex. There's a lot of steps that are required to be done. And in each of those steps, there's a lot of different types of tasks that people do today. And finding a specific area to introduce automation can be very challenging, trying to match what's technically possible today with what customers would find valuable. And After doing a lot of this investigation, especially with some clients' old customers, we ended up settling on building facades as a great starting point. And this was for a couple of reasons. The first is that this is an area where work is already very standardized today. When our customers go out to site, they have a system that they use project after project, and the work process is the same on every single project. And as a result, because there's a lot less variability in the work that our customers require to perform at site, the automation problem became a lot easier and a lot more feasible to solve. Another nice thing about facades is that they're typically one of the most expensive parts of any building. And for good reason, it's the first thing you'll see on any building. And so contractors and custom and owners are very incentivized to invest heavily into making sure this part of the process goes right and to really invest in technology that can help improve productivity. And finally, the work for installing facades is some of the most challenging on any building. It requires people to work in very uncomfortable and sometimes physically dangerous situations in order to get the job done. You're always working on the edge of the building, and once buildings get tall, that can be hundreds of feet up in the air. And a lot of the work access problems, you're always working on from the inside of the building and trying to access the edge of the slab. And so the work positions become very physically demanding. And so once we actually found a problem to solve, then we started working really closely with our customers. And one of the early ones was a company called JR Butler. And we actually worked with the same customer group over and over again, deploying robots out on site. And every time we went on site, we would discover more problems and solve them and make new iterations of the robots. I think one thing that really helped us out here is that some of the early adopters in our customer base were very patient with us. Every time we had issues, they would continue to support us and offer resources in helping us address these issues and work through them and continue to give us opportunities to deploy on site. And this allowed us to make sure that the robots that we were building worked out in the real world, not just in a lab environment. And so then when we actually went out to scale up the deployments and deploy robots, they actually did the job that was expected of them. But of course, this, like I mentioned, there were a lot of challenges that came up as we started deploying more robots. One of these you can see here during testing, we ended up having a robot actually fall over. And this was actually something we did on one of our partners' test sites. It's a company called DPR, general contractor based in the Bay Area. And they were gracious enough to let us test the robots on one of their concrete yards. And luckily we were able to discover this issue before we ever deployed machines out onto site. And I will say that building robots for these more unstructured environments is a very challenging process. The way we always think about it is anything that can go wrong will go wrong. And so one of the biggest benefits to having industry partnerships is allowing us to really find out what could go wrong and then making sure we address these problems ahead of time. When we're operating in these outdoor environments, there's a lot of weather that the robots get exposed to: rain, snow, actually even lightning. And so these are things we have to keep in mind to design both in terms of to design around in both the engineering as well as work around in terms of operational procedures. There's also a lot of obstacles that the robots can encounter on site. And these are all potential impediments to robot operation in the case that the robots end up colliding with the obstacles or they block access to the site. And again, things that we have to design the robots to avoid, to make sure that robots can avoid these obstacles and do their work. And then once you start running robots on site, you get into very interesting potential user errors that can cause issues in operation. You can make the robots work perfectly in the lab with people who know how to use it. But once you start operating them out in the field, there's other things you have to deal with in the UI to actually make sure that we're trying to make sure that users can't enter the wrong information and make sure the robots do their jobs correctly. And of course, finally, just robot issues that can pop up when there are things that go unexpectedly. But again, having customers who kind of help support us through this process of figuring these issues out one by one and working through them has been very instrumental in getting our product to where it is today. And now we've just passed over 35 hours of operation with our machines on site. And actually that first company I mentioned, JR Butler, that we worked with for the first couple of years of product development, on one project, they actually ran into huge issue with one of the subcontractors they hired to do some of this work. And that ended up costing them over $100,000 in rework and adding a couple months on schedule. And by bringing our robot on site, we were able to address these issues and fix them, and also cut another 2.5 months off the schedule, bring them back to closely where they were originally hoping to be, and thereby actually helping them save the project. And today we're working with a pretty wide customer group now, customers all across the United States, and deploying robots with them on project after project. And just touching a little bit more about what we can do with the robots currently. So we support 3 applications in production and 1 currently that we're still doing development on. You saw some of these in the video earlier, doing layout marking, drilling, and site scanning. Here, what we see a big value of our robots are first of all, reach. With all of the applications that we do today, when we're working on the edge of the building, people no longer need to be tied off and actually physically being at the edge. They can work behind the edge guarding, and the robots have the physical capability to actually reach around and access these these locations that would be hard for people to actually access. And another big benefit of our robots is accuracy. We're able to position our robots within about 3.5 millimeters of absolute accuracy anywhere within the robot's operation. And so that provides a lot of reliability that is hard to achieve with manual labor today. And just talking about some of the fundamental technologies that actually allow our robots to accomplish these tasks. The first, like I mentioned, is positioning, getting that accuracy. We locate our robots on construction sites today with a piece of equipment called a total station, which is used typically to do survey. And this allows us to position the end effectors very accurately within the construction sites. We also do a lot of work on computer vision for our robots to actually perceive the environment around them and actually know what's there. And here we use LiDARs as well as vision sensors. And we do a lot of work actually on machine learning techniques to help our robots detect certain obstacles that might be hard to see. And finally, we make a lot of work of force sensing technology. When our robots are doing operation, they're actually maintaining contact with the sites so that they know exactly where the objects are and they're making sure to do the job correctly. And moving forward from here, we said there's a lot of opportunity to introduce automation into different areas of construction as well as other related areas. And so here, there's a couple of different things that we're exploring right now. The first is expanding our tooling into other applications. Some of the things that our customers have requested are different applications like welding studs onto steel, caulking joints, doing subsurface scanning. And we're also, like I mentioned, starting to work on new access platforms. This is something where we're actually, again, pursuing an industry partnership, partnering with existing OEMs for manufacturing these work access platforms and integrating our robots onto them. We've also started seeing some success in actually using our software on other machines. Recently, we started working with a 3D printing concrete company who was struggling to get their robots to be positioned accurately on site. And there we were able to integrate some of our software stack to allow them to localize the robots and print over a wider area. And today we do see that this is a very exciting time to be bringing robots into this space. Recently, in the last couple of years, there's been a lot of startups that have come out, as well as some larger companies who have started investing into automation for these type of construction sites and outdoor environments. I think a lot of the technologies that have been developed over the last few years in robotics, sensing, and actuation are now really starting to make a difference in what types of automation products you can build. And we're very excited to be on this journey and continue to work with our customers. And we're definitely very open to seeing if there's any other use cases that folks here might be interested in, seeing if there's a potential to automate. And if you guys would like to learn more about our specific technologies, please feel free to ask questions after this presentation. Also reach out to Colleen or I directly. And that's all I have to share for today.
Well said, Gary.
All right. That's very interesting and very good stuff. Okay, audience, come on. Gotta have some questions for these guys. This is really exciting to see something that's truly a help in the shortage of craft workers and tackling what's really dangerous work to be done by a machine instead of people and putting people at risk. So I have one question while we're waiting for a brave person. Can your robots communicate in real time with a control system so that it can feed production control and know what's done, what's being done, what's not done, status of the work?
Yes. So our robots are all of the control for actually actuation and all the software for sensing. It's all run on the device itself locally, and so it's all happening in real time. But we also do connect the robots over to cellular, so 5G, 4G networks, and so we're always streaming data back into the cloud so that there's a constant updates of what the robot's doing, and that way our customers know exactly what work's been done, and if there's any issues, they can get notified as quickly as possible.
Mm-hmm. So what's been the acceptance at the job site by construction workers? It's eager, it's, oh no, they're taking my job.
I think it's definitely developed over time. When we started the company, I mean, coming from crane and rigging, my initial concern was, this is a robot going to a job site. Like, this is insane. And if the union's not going to be on board, this isn't even a venture worth taking. I mean, they have the power to kind of kill it. So it was the first conversation we had. We talked to the operating engineers before we incorporated, kind of got the green light from them. This is a technology they'd be interested in. And once we got more, I would say, deeply rooted in the facade marketplace, we've set up in a partnership with IUPAT, so America's largest labor union, that services all the finishing trades, glazing, etc., across the United States. We just kicked off our collaborative training program this week, just got back from it. So we're going to be rolling out our first 12 certified trainers across states that are going to be actually training district councils across the United States. As the product improved, that's definitely helped the conversations as well as kind of feedback from the teams. At first it was something that was viewed as more of, research and, a science project at the end of the day to a lot of people in the trades. But now we're actually, delivering substantial value to their projects, and it's just viewed as, a net benefit for them to adopt it. It's viewed as a piece of equipment and a tool that allows them to do more, reduce risk, reduce rework, and ultimately deliver better projects and win more work at the end of the day. So the conversation's changed, over time with kind of industry dynamics as well as product development getting better.
That's good to hear. Couple of questions for you, trying to get some brave folks. Any thoughts about moving into humanoids?
Yes, we get asked this a lot.
You get asked that a lot, yeah.
There are definitely thoughts. I would say it's not like an immediate priority. The construction sites are a very challenging space to operate, like even with a simpler robot. And so I think it's going to take a while before something like a humanoid, it's technically possible to implement on a construction site. I will also say that I think that there are certain tasks that a humanoid might be suited for on a construction site, but there's a lot of work that humans really just aren't suited for today, right? Like we see a lot of people just like leaning outside of like a scissor lift or a man basket trying to reach a location, or like I showed right in the pictures from before, like if you had a humanoid robot doing some of the work we have today, this is what the humanoid robot would be doing, right? And that's not really the ideal work process. Like you don't really want a humanoid robot crouching on the edge of a slab to do that work. You want a different form factor that's designed specifically for these type of locations.
I totally understand. So let's see, I got another question here. Have you looked at or considered the application of robotics in heavy construction?
Yes. So when we were doing kind of our use case exploration, we actually started looking at, I would say, more volumetric installations in nature. We had started looking at bridge girder installations. I mean, from my experience, that was where we had a lot of worker risk and a lot of our injuries were from moving, hundreds of thousands of pound girders into place. The limiting factor for us during that exploration was the state-by-state structural codes that kind of change, what an abutment is going to look like in each state, and it leads to a lot of complexity in hardware design. So it's been put on the back burner as far as just like heavy civil girder installations, but we are getting into more horizontal applications right now with the addition of the hammer drill tool, the subsurface scanner. And as we continue to develop new tooling, it's just going to expand what we can attack in the marketplace.
Okay, so I get another question on data. Do you see any limitations regarding what type of data can be gathered by the robots you use today? If so, what? What type of data do you capture today as the robot does the work?
Yes, that's a good question. So there's definitely always going to be limitations in the types of data that's captured. But I would say like the way we structure our robots is to make the machines very modular, where we can continue to add additional sensors in response to our customers' requests and improve the data capture. What we see today, the most valuable piece of data for our particular customers right now is the ability to know exactly where things are on site. A lot of the challenges that our customers face today is when things aren't installed incorrectly, or where previous trades who've done their work end up being out of tolerance, but our customers don't know until it becomes too late, leading to very serious rework. And so by being able to get this information to them ahead of time, that allows them to get ahead of problems, and resolve them before it's too late. The specific data that we are offering to our customers right now, it's either in the format of point clouds, or if they like post-process them into a CAD model. We are also, like Colleen mentioned, starting to work on subsurface scanning, where we can actually capture information about what's beneath the surface.
Okay, kind of along with that, do your robots record existing conditions, particularly in respect to backing up a delay in install?
Yes, that's exactly what we do with the point cloud and CAD data.
Okay. All right. So another question here. This is really good. We're getting some questions. Do you find the setup for operations to be shorter or longer compared to manual operations?
Right now, it's
I
about
think the setup, yeah, it's the exact same. So, I mean, if you're comparing us against looking at specifically the layout application, you're setting up a total station the same way, you're inputting your coordinates the exact same way. It's the same information that you would have had for manual layout or installation. That's all that we require with our robots. So that's a key differentiator for us, is just the ability to drag and drop them between job sites very easily. Gary and I picked one up in Nashville, drove it over to Memphis, and started it the next day. It's typically 30 minutes to an hour to get us going.
Great. What will be the biggest enabler for increasing robotics at construction sites in the future?
Yeah, I think this is a very interesting question. I think the biggest thing from our side that really helped us get started were really those industry partnerships. Robotics is, I think, one of those products where it's more of a collaboration rather than just purely selling, a piece of hardware to your customers. It's because you're not really selling a robot at the end of the day. What you're trying to do is provide automation and use that automation to solve a specific problem in your customers' processes. And that requires working really closely with your end users in order to make sure that the machine's doing the correct job and working on the right task. I think that is the first thing that will really unlock additional automation. It's just folks in the industry being willing to provide time and maybe some resources to help robotics companies develop products.
Yeah, I do think there's a little bit of like siloed communication right now in construction technology. I mean, all of the construction robotics, we all know each other very well, but the larger industry is kind of just starting to pick up on, advancements that have happened 3 years, 4 years ago. That is an area that I think just needs to be improved as an industry, and that's facilitated by more on-site opportunities, testing these things out. Construction sales, at the end of the day, it's a show me industry, not a tell me industry. I can't just blindly sell a contractor a robot. We have to show them that it actually adds value before they're going to buy it.
Along those lines, other than safety and reduction of schedule, are there other benefits such as cost or quality of the work to utilizing the robots instead of humans for performing work at a specific project sites that your robots have been deployed to? If yes, what are such benefits, and what do you think the deployment of such solutions to a wider variety of sites will be like? Have you carried out any study in that regard? Are there any potential drawbacks?
Mm-hmm. Okay, so on the value added, it definitely, yes to all of these. We just published a case study today highlighting, the benefits that we added to the St. Jude project. saved on safety, reduced the schedule, decreased cost compared to manual methods, and then increased quality. So we hit all of those major buckets. I will say that it depends on the contractor that you're working with and kind of what their specializations are. Are they a contractor that's going to third-party labor right now? I mean, you're going to see immediate benefits. Are they a contractor that is limited on throughput with just too many projects going on? They have good guys, but they can't get them out to all the projects and job sites. It's going to depend on what their core specializations are right now and how they're structured. But obviously, there's always a safety benefit. There's always a cost benefit associated to it, as well as the schedule and quality as well. Our quality has superseded what we've seen manually on every project we've been on so far. When we start the projects, we typically do a composite layout for 1 or 2 floors or composite installation and actually, prove it to the contractor at the end of the day. We are delivering a better quality product than the traditional methods, and we're getting it done safer. Potential drawbacks, kind of going down that same thread. Being a robot, it's working off absolutes. And I think that's, one of the beauties of manual labor in the field right now is there are a lot of things that just get swept under the rug that are field fixes that never get communicated. And it's someone with 30, 40 years of experience that's able to, work through drawing issues. I mean, they're not really going through and actually looking at every single point and making sure they're in the right spot. So I would say, a potential drawback is if your inputs to contractors are incorrect, you have different drawing revs that have been submitted to different contractors, the shop drawings are derived from different starting points, you will end up with more issues in the future. But I do think this is also an opportunity to kind of collectively rein in all those loose ends with drawing submittals, make sure everyone's working off the same set at the end of the day and have a more cohesive data share between contractors.
Yeah, just brought the focus on a real problem we have in the industry with accuracy of the work. Really good point. Well, gentlemen, thank you for your time today, sharing your thoughts. I suppose if people want to follow up with you, they're interested in an application, they just need to reach out to one of the two of you and get to work.
Absolutely. Thank you for the opportunity.
Thank you.